Good morning, students. Chapter 7, System of Particles and Rotational Motion. In last lecture we have discussed about what is angular momentum, relation between angular momentum and torque, and yes, conservation of angular momentum. Okay. Now in this lecture we will see about one topic which is called equilibrium of rigid body. Equilibrium of rigid body, it means what? See, rigid body is said to be in mechanical equilibrium. In mechanical equilibrium if linear momentum and angular momentum are not changing with time. Or you can say or linear acceleration and angular acceleration of rigid body is zero. Clear? So yes, it is one statement that you have to remember. Okay, rigid body is said to be in mechanical equilibrium if linear momentum and angular momentum are not changing with time, means they remains constant, or linear acceleration and angular acceleration of rigid body are zero. Clear about this? Okay, so yes, see, rigid body, in some cases there are numbers of forces acting on rigid body. Okay, so if we take the vector addition of forces, and if the vector addition of forces is force zero, so yes, linear momentum remains constant and acceleration is zero. It means it is in linear equilibrium. It is in linear or translational equilibrium. Next, okay, if due to their forces about some point, if resultant of torque is also zero, torque zero, then we know that angular momentum remains constant, and yes, torque zero means angular acceleration is also zero. So yes, in such cases, object is said to be in rotational motion. Okay, so now here it is. See, rigid body is said to be in mechanical equilibrium if linear momentum is not changing with time. Now we know that, see, first, okay, if forces acting on rigid body are F1, F2, F3 dash. Okay, and if total force or resultant force F is equal to F1 plus F2 plus F3 plus S2 plus so on is zero, means total force is zero, resultant force is zero. Therefore, if resultant force on rigid body is zero, we know that linear momentum does not change with time. Okay, does not change with time. And yes, if force is equal to zero, then also acceleration is zero. Linear acceleration is zero. Clear? An object is said to be is said to be in linear equilibrium, or you can write translational equilibrium. Translational equilibrium. And yes, you already know this topic in chapter number 5, equilibrium of particles. Okay, if forces acting on particle, their resultant is zero, then that object or that particle is said to be in equilibrium. But it is called linear equilibrium or translational equilibrium. Clear about this? Again, if forces acting on rigid body are F1, F2, F3 dash dash dash, resultant force is zero, then yes, linear momentum does not change with time, or we can say acceleration is zero, and object is said to be in translational equilibrium. Clear about this? Similarly, second, okay, if torques acting on rigid body are tau 1, tau 2, tau 3 dash dash dash, okay, and resultant torque that is tau is equal to tau 1 plus tau 2 plus tau 3 plus s2 plus so on is 0, okay. If resultant torque on rigid body is 0. So yes, we have discussed in last lecture, its angular momentum does not change. Its angular momentum does not change with time. Or you can say angular acceleration is 0. Angular acceleration is 0. And object is said to be, or body is said to be in rotational equilibrium. And object is said to be in rotational equilibrium. Simple. So yes, you have to remember these 2 points. Okay, rigid body is said to be in mechanical equilibrium if it is in translational equilibrium and rotational equilibrium. What is condition for translational equilibrium? That total force 0. What is condition for rotational equilibrium? Total torque 0. About some point. Clear about this? So yes, for rigid body to be in mechanical equilibrium, these 2 equilibriums are required. Yes, in some cases you will see that sigma f is equal to 0. Listen, okay. Sigma f is equal to 0, but sigma tau is not 0. It means it will perform only rotational motion. Another case is if sigma tau is equal to 0, but sigma f is not 0, means it is performing linear motion. Okay, so here I am writing. Okay, here I am writing. Okay, in some cases, okay, when sigma f is equal to 0, but sigma tau is not 0. Okay, if sigma f is equal to 0, but sigma tau is not 0. Okay, so therefore object sigma f is equal to 0, but sigma tau is not 0. So object is in translational equilibrium. Okay, means it will not perform any linear motion. But it is not in rotational equilibrium. Okay, it will rotate. It rotates. Simple. So yes, this point you have to remember. If on rigid body total force is 0, means it will not perform linear motion. It is in translational equilibrium. But sigma tau is not 0, means some torque is acting. So due to that torque it will perform rotational motion. Due to that torque it will perform rotational motion. Clear about this? So yes, this point you have to remember. It is all about equilibrium of rigid body. Okay? Next topic is couple. Now what do you mean by a couple? Not that, okay. See, what is couple in physics? What is couple in physics? See, here it is. Yes, you know some examples. For example, if you are on two-wheeler, okay, so yes, your steering is like this, okay. And if you want to take right turn, so yes, you have to move your steering like this. Yes or no? See, you have to move your steering like this. Okay, this hand towards you and it is away from you, means in opposite direction. Yes or no? Yes. If you want to open, okay, any bottle, it's cap. If you want to remove cap, then how to rotate that cap? Okay, yes, you have to hold like this and then you rotate, yes or no? Yes, it is. In car, if you want to take turn again, if it is steering like this, then you have to rotate like this. See, these two hands are moving in opposite direction. One in this direction and another in opposite direction. So what happens due to this all types of forces? We will see. See, couple. What is meaning of couple? If I have one rigid bar shown in figure. Two forces. First F1 and second, suppose F2. These two forces are acting like this. And if these two forces have equal magnitude, see, okay, if two forces have equal magnitude, opposite direction, and not co-linear. See, what is meaning of not co-linear? F1 and it is F2. Just they are in opposite direction. From figure it is clear. They are of equal magnitude. We have assumed, okay. But what is meaning of not co-linear? If it is one particle, force F1 is acting in this direction and F2 is acting in this direction. So they are collinear because their line of action is common. But see, in this case, line of action of F1, here it is, line of action of F2, here it is. And see, they are not same or they are not intersecting. So yes, we can say if we have two forces of equal magnitude, opposite direction and not co-linear, see, the line of action is not same. So they are not co-linear. So two forces have equal magnitude, first condition, okay, opposite direction, second condition, and not co-linear, they form a couple. Clear? They form a couple. And what happens due to this couple? So due to couple, torque is produced. And object performs rotational motion about a fixed point. Clear about this? What happens due to this torque? So yes, due to couple, torque is produced, an object performs rotational motion about a fixed point. Why only rotational motion? Not linear motion. Because see, equal magnitude, opposite direction. Okay, here resultant force is 0. Here resultant force is 0. Why resultant force is 0? Two forces have equal magnitude and opposite direction. So yes, here resultant force is 0. Therefore, object is in translational equilibrium. It is in translational equilibrium. Translational equilibrium means no linear motion. Clear about this? So yes, it is theory about couple. Okay, if you have two equal magnitude of forces, opposite direction, not collinear, they will form a couple. Due to couple, okay, torque is produced, an object performs rotational motion about a fixed point. What about linear motion? So as resultant force is 0, it will not perform any linear motion. In this case, what happens? See, in this case, as if it is fixed point, okay, so if you are applying forces like this, first force happen in upward direction and second force happen in this direction, then obviously this object will perform rotational motion like this. Okay, this wire will perform rotational motion like this. If it is in this direction, it will perform rotational motion like this. Simple? Yes or no? Yes, it will perform rotational motion. Clear about this? Now we have to obtain equation of torque due to couple. Okay, for that, see, here it is. Let it is x-axis. It is y-axis. Origin. Let it is point P. Okay, and here it is, let point Q. Okay, position vector of point P is R1. Position vector of point Q is R1. Force acting on point P is F1. Force acting on point Q is F2. Like this. Any doubt? Okay, so yes, we have two particles P and Q. Their position vectors are R1 and R2, and forces acting on them are F1 and F2. Clear about this? Okay, so yes, here, what is total torque or resultant torque? Resultant torque acting on system, with respect to point O, means this point. So total torque, tau is equal to torque acting on first particle plus torque acting on second particle, torque acting on point this particle and torque acting on this second particle. Okay? Okay, so see, suppose it is tau is equal to tau 1, it's tau. What is torque? Equation of torque. Torque is equal to, it is R cross F. So yes, R1, F1. So yes, I can write it is R1 cross F1 plus tau 2. What is force acting on second particle? F2. Its position vector R2. So it is R2 cross F2. Simple? Okay, as we have two particles, forces are 2, position vectors are 2. So yes, total torque is equal to torque acting on first particle plus torque acting on second particle. So torque is equal to this R1 cross F1 plus R2 cross F2. But see, here it is. What is condition? Equal magnitude and opposite direction. So it means what? Equal magnitude and opposite direction means I can write F1 is equal to minus F2 or F2 is equal to minus F1, or F2 is equal to, it is minus F1. Yes or no? Yes. So here is equal to, it is R1 cross F1 minus R2 cross F1. Any doubt? Any doubt? Okay, R1 cross F1 minus R2 cross F1. Okay, this F2 is replaced by minus F1. Okay, so yes, now I can write this as R1 minus R2 cross F1 common. Cross F1 common. Okay, see, cross F1 common. So it is R1 minus R2 cross F1. Any doubt? Any doubt? Now, what is R1 minus R2? See, R1 minus R2, it is in this direction. It is R1 minus R2. It is R1 minus R2. Clear about this? Yes, it is R1 minus R2. Now I am assuming, see, I am assuming that this angle is theta. So obviously this angle will also be theta because these two forces are in opposite direction. Okay. Now see, first vector is R1 minus R2 and second vector is F1. It is torque is equal to R1 minus R2 first vector and another vector is F1. R1 minus R2, it is actually in this direction. It is actually in this direction. Yes or no? It is direction of R1 minus R2 and it is F1. So see, whenever you are given cross product A cross B, how to find its magnitude? A cross B, how to find its magnitude? Its magnitude is AB sin theta, where theta is angle between two vectors, that is A and B. Here we have two vectors. First is R1 minus R2 and second is F1. So what is angle between R1 minus R2 and F1? Here it is R1 minus R2 and here it is F1. So angle between them is this, that is pi minus theta, 180 minus theta. 180 minus theta. Okay, because this whole angle, see, if you are given one line like this whole angle is, it is pi. This whole angle is, it is pi. Clear about this? Okay, so yes, its magnitude, how to write its magnitude? How to write its magnitude? Its magnitude we have to write as, as shown in figure. See, the tau is equal to this mode of R1 minus R2 F1 sine. What is angle between R1 minus R2? See, it is R1 minus R2. Okay, and it is F1. Angle between them is, it is pi minus theta. It is pi minus theta. Clear? So yes, that tau is equal to, it is F1 mode of R1 minus R2 and here it is sine. And here it is sine theta. Any doubt? Any doubt? Okay, now R1 minus R2 sine theta. See, I will draw one line like this. Like this. So this pink line, it is nothing but perpendicular or shortest distance between F1 and F2. F1 and F2. See, it makes angle 90. It also makes angle 90 here. So see, this distance, this pink chalk, okay, it is the shortest distance. It is the shortest distance between two forces. Let they are named as, it is let O. Sorry, it is O is already given. So let it is N. Let it is N. So this NP is shortest distance between two forces. Shortest distance between two forces. And see, what is relation? If I am taking this triangle, in this triangle apply sin theta. So yes, you will get sin theta is equal to, sin theta means opposite side, that is NP upon hypotenuse. The hypotenuse is nothing but it is R1 minus R2. So R1 minus R2, if you take this side, so it is R1 minus R2 is equal to, it is, sorry, R1 minus R2 sin theta is equal to, it is NP. Is equal to, it is NP. So here I can replace this tau as, see how to replace this tau. Okay, see how to write this tau. This tau is equal to, it is F1. R1 minus R2 sin theta is replaced by NP. is replaced by NP. Clear about this? Clear about this? Or you can also write or tau is equal to it is F2 NP. Why F2? Because two forces, they are of equal magnitude. So now from this we have to write okay, what is torque due to couple? Torque due to couple is equal to F1 or F2 means magnitude of any one force. Magnitude of any one force into what is NP? NP is perpendicular distance between two forces. It is perpendicular distance between two forces. Is perpendicular distance between two forces. Clear? See again, one force is F2, one force is F1. So it is not perpendicular distance between them. No, see, it is not making angle 90. It is not making angle 90. But this distance, this pink one, see, it makes angle 90 here. It makes angle 90 here. So it is called perpendicular distance. So it is called perpendicular distance. Clear about this? So this point you have to remember, and see, this couple is important. Yes, what you have to remember? You have to remember only this equation. Okay, torque due to couple is equal to magnitude of any one force into perpendicular distance between two forces. Clear about this? So couple is one important topic, because in 12, in chapter number 1, 4, 5 and 6, yes, in this all chapters you have to apply some concepts regarding to couple. Okay, so what is couple is one important topic of this chapter. Okay, what is condition? Again, three condition: two forces, equal magnitude, opposite direction, they will form a couple. Due to couple, object performs rotational motion. Due to couple, object performs rotational motion because torque is produced. Clear about this? Any doubt? So yes, you have to remember this definition. Torque due to couple is equal to magnitude of any one force into perpendicular distance between two forces. For example, it is force F, and this length is L, and here torque is equal to it is force into length. Because see, perpendicular distance between these two forces is nothing but this length L. This length. Okay, so yes, you have to remember this concept. It is very important. What is couple? Okay, and yes, for today's lecture, this is it.